In this video, I will talk about the standard enthalpy of formation and also how to compute the standard enthalpy of reaction given the standard enthalpy of formation of all reactants and all products. First, let's define standard state, denoted by this O in superscript. For pure gas, its pressure must be 1 bar. Before 1982, 1 atm is used for the standard state of a pure gas. It's still used in many textbooks. For a gas in a mixture, its partial pressure has to be 1 bar to be in the standard state. For example, if you have 1 bar pure oxygen, it's in the standard state. But if you have 1 bar air, neither oxygen nor nitrogen is in the standard state. For a liquid or solid, it has to be pure and feel 1 bar external pressure for that liquid or solid to be in the standard state. For a solution, if the solute has a concentration of 1 molar, we say the solute is in the standard state. Now let's define standard enthalpy of reaction. The enthalpy change of a reaction in which all chemicals are in their standard state. So every single reactant and every product must be in their standard state. This is a hypothetical case because in the real world it's very difficult to find any chemical reaction in which all reactants and all products are in the standard state. Standard enthalpy of formation. It's denoted by delta H sub F superscript O. The standard enthalpy of reaction in which all reactants are pure elements. So, in addition to the condition for the standard enthalpy of reaction, we want to emphasize this. The standard enthalpy of formation reaction are the reactions in which all reactants are pure elements, and each pure element is in its standard state. The standard enthalpy of formation is set to 0 for all pure elements at 298 K for convenience. So what about other temperatures? As long as the temperature is not much different from 298, let's say 300 K, 320 K, let's say 280 K, the enthalpy of formation is approximately 0 for those pure elements. The standard enthalpy of formation is often measured at the room temperature, just for convenience. And again, it's defined to be 0 for pure elements at 290 K for convenience. Now let's look at the standard enthalpy of reaction. It's very simple. Enthalpy is a state function. So the standard enthalpy of reaction is simply the standard enthalpy of the products, which is the final state, minus that of the reactants, which is the initial state. So we use this equation to compute the standard enthalpy of reaction given information of the products and reactants. Example problems. Again, we're going to assume the temperature is 290 K. Again, because if the temperature is slightly different from the room temperature, you still have roughly the same value of the standard enthalpy of reaction. H2 reacts with CO2 to produce HCl. Very simple. You look up the enthalpy of formation of HCl, which is negative 92 kJ per mole. multiply that by the coefficient 2 here. And then minus the enthalpy of formation of the reactants, which happens to be 0 because H2 and CO2 are pure elements. And we're talking about 298 K. So the result is simply negative 184 kilojoule per mole. It's exothermic. Hydrogen combusts in oxygen. Again, we do the same thing. We have one water. The enthalpy of formation of water is negative 242. And minus the reactants. For hydrogen it's 0. For oxygen it's 0. Again, we're talking about the standard enthalpy of reaction. We assume all chemicals are in the standard state. The result is negative 242. It's an exothermic reaction. The same reaction, but wait, pay attention here. Over here, we are producing liquid water. This is gaseous water. The enthalpy of formation of liquid water is negative 286 kilojoule per mole. It's different from this one. Okay, but same, it's a exothermic reaction. Again, we're talking about the standard enthalpy of reaction. We assume all chemicals involved in the reaction are in their standard state. One last example. From liquid water to gas water. Very simple. The standard enthalpy of formation of gas water, negative 242, minus the standard enthalpy of formation of liquid water, you get plus 42 kilojoule per mole. I'm sorry, there's a mistake. Plus 44 kilojoule per mole. And this is positive. This vaporization of water is endothermic. The enthalpy of water increases. Now, practice problems. Let's determine the standard enthalpy of reaction for the following reactions. Again, at 298 K for convenience. First, chemical reaction. Second, the second reaction is simply the first one multiplied by 2. So what you need to do is you need to look up the value of the enthalpy of formation of CO and CO2. What about this one? I'll let you think about it. What's the value of the standard enthalpy of formation of this oxygen gas? The answers are in font size 2. Again, if you just Google enthalpy of formation and Libra texts, you'll find this website with a lot of numbers regarding the standard enthalpy of formation for many chemicals.